Getting started on chapter 8, we're going to be hearing the term rational expression quite a bit in this chapter. So to get us started, let's understand what that term actually means. So we've heard the term a rational number. So remember in the beginning of class, in chapter 1, we determined that a rational number is any number that can be put into a fraction, that can be turned into a fraction. So a rational expression is going to be an algebraic expression that is a fraction. So in this chapter, we're going to be learning how to simplify rational expressions, as well as multiply, divide, add, and subtract rational expressions. So we're just going to be touching on the basics. And I have a few examples up here of what a rational expression would be. So in here, we've already seen some like this in chapter 6 when we were going over our properties of exponents. We had a lot of monomial terms, a monomial divided by a monomial. And so this would be a rational expression. We also have a couple examples where we have a binomial divided by a binomial. Now, later on in other videos, we'll be looking at trinomials divided by trinomials as well. So a rational expression is just where we have an algebraic expression on top divided by an algebraic expression on the bottom. So the reason why I put these up here, the first section in your homework is just asking, how can we make these rational expressions so that there's a zero in the bottom? So we want to make these rational expressions undefined. And remember, the term undefined means that there's a zero in the denominator's spot. So why don't we go ahead through each of these and just try to understand that concept, so that'll get you started on the first section of homework. So in the first one, we have 10m divided by 11n. But to make a rational expression undefined, we're only looking at the bottom. It doesn't even matter what the top is. So just look at the bottom and see what the variable needs to equal in order to get it by itself, or to get the variable by itself. But what does the variable need to equal so that the bottom equals 0? So in this case, 11 times what is going to equal 0? Well, 11 times 0. So the only number that n could be is 0. 11 times 0 would equal 0. Now let's look at our second one again. In order to make a rational expression undefined, we're only looking at the bottom. It doesn't matter what the top is. So for this one, again, we want to get the variable by itself, and then we'll have to determine what it's going to equal. So in order to get the variable by itself, I'm going to have to divide both sides by 4 so that the 4's on the left will cancel out. And then I'm going to have y minus 9/4. So remember, in order to get this to equal 0, the y is going to have to be the opposite of the constant. So y is going to have to equal a positive 9/4. Now that positive sign is not necessary to write, so just 9/4. So 9/4 minus 9/4 will equal 0. Therefore, the whole bottom would equal 0. In our last example, we're just looking at the bottom again. We have b squared minus 36. That should ring a bell here. This is a pattern. This is a special product. This is a difference of squares. So we can factor this into two sets of parentheses, because we can take the square root of b squared, which is going to be b. And since this is a difference, we know that we're going to have a plus and a minus, and then 36. So I know my b's kind of look like my 6's, but it's going to be b plus 6, b minus 6. And so now that we have that factored completely, we can go ahead and determine what b will have to equal for this bottom to be 0. In the one, it would have to be a negative 6, and in the other set of parentheses, it would have to be a positive 6. So we could just put plus minus 6. So these are just a couple of examples of rational expressions and how to make the rational expression undefined by getting the bottom to equal 0.